Hi class. In this video, I'm going to be talking about some probability example problems. So the first problem I have is this one here. Here I'm given a tree diagram. The following tree diagram shows the sample space for flipping a coin and rolling a six-sided dice. And I want to fill in the outcomes and then answer these questions here. So starting with the tree, if I flip a coin, there's only two options. Either I get heads or I get tails. Now, after I flip the coin, if I roll a dice, I have six options. I can get 1, 2, 3, 4, 5, or 6. So, outcome is I flip a coin, I get heads, then I roll a dice and I get 1. I flip a coin, I get heads, I roll the dice, I get 2. I flip the coin, I get heads, I roll the dice, I get 3. Now, I flip the coin, I get heads, I roll the dice, I get 4. Flip the coin, I get heads, roll the dice, I get 5. And if I flip the coin, I get heads, and I roll the dice and I get 6. Now for the other one, if I flip a coin and I get tails, now if I roll a dice, I could get one of these six options. So tails and 1, tails and 2, tails and 3, tails and 4, flip the coin, get tails, roll a 5, flip the coin, get tails, roll a 6. Okay, so there are 12 outcomes in total. Okay, so I'm going to write that down. I have 12 possible outcomes. That's what I learned from this sample space here. 12 outcomes in total. Okay, now let's answer these questions. For A, it asked me what is the probability of h comma 6, meaning what is the probability of flipping a coin, getting heads, and then rolling a dice and getting 6. Well, if you look on the sample space here, there's only one possible outcome where I can flip a coin and get heads and then roll a dice and get 6. Only one possible outcome. So the outcome that I want is going to be on the top. And it's always going to be divided by my total possible outcomes. Since I have 12 possible outcomes in total in this sample space, the answer is going to be 1 divided by 12. So that's my probability. Now, I don't have to do this, but if I really wanted to, I can say this also can equal to 0.083 repeating as a decimal, or 8.3 repeating percent. I only do that if I'm asked to express my answer as either a decimal, a percent. If I'm just not asked, I can leave my answer as a fraction. Now, the second question is, what is the probability of t, comma, odd number? So what that means is, what is the probability of flipping a coin, getting tails, and then rolling the dice and getting an odd number? So for this one, I have 12 outcomes in total, once again. So my total possible outcomes is 12. That never changes. I just have to find out what my numerator will be now. So it looks like here, if I flip a coin and get tails and then I roll a 1, 1 is an odd number. So that's a possibility. If I flip a coin, get tails, and then I roll a 3, 3 is also an odd number. And if I flip a coin and get tails and then I roll a dice and get 5, 5 is also an odd number. These are the only 3 that satisfy my criteria out of the 12 possible outcomes that I have. So my probability for flipping a coin, getting tails, and then rolling an odd number would be 3 out of 12. Or if I were to reduce this, I can divide both the top and bottom number by 3 to get 1/4 as my probability for flipping a coin, getting tails, and then rolling an odd number with a dice. Now for C, it asked me, what is my probability of flipping a coin and getting heads, and then rolling a dice and getting the number 7? So for this one, I'm going to say not possible. And the reason it's not possible is because the number 7 doesn't exist on the six-sided dice, right? That's why this would be a question that I can't possibly answer. Okay, now let's go over another example problem. For this example problem here, a four-sided dice So this is my four-sided dice here. It is labeled 1, 2, 3, and 4. And then I have a spinner, which is labeled 3, 6, and 9. I'm asked to create a table to show the sample space. So this would be my sample space table. So let's start with the spinner as my column. So in this case, my options for the spinner would be 3, 6, and 9. So let's write that down. 3, 6, and 9. Okay, now my options for the four-sided dice would be 1, 2, 3, and 4. So we're just going to create a table from that. So I'll call this my dice here for this row. Okay, now I'm just going to fill in that sample space. So if I spin the spinner, I can get 3. Then if I roll the dice, I could get 1. If I spin the spinner and I get a 3 again, I could roll the dice and get 2. If I get a 3 on the spinner and I roll the dice, I can get 3. And if I spin the spinner and then I roll the dice, I could also get 4. So those are all the possible outcomes I can get if my spinner lands on 3, and then that's all the possible outcomes for the dice, my four-sided dice. I can also spin and land on 6, and then I can get a 1 when I roll the dice. I can spin and land on 6 and get a 2 when I roll the dice. And then land on 6, roll and get a 3, and land on 6, roll and get a 4. And then finally, I can also spin the spinner, land on 9, and then roll the dice and get a 1. I could also roll the dice and get a 2. I can also roll the dice and get a 3. And finally, I can also land on a 9 for the spinner, roll the dice and get a 4. So notice my total possible outcomes here from this table. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total possible outcomes. So I'm going to write 12 possible outcomes. Now, if you're just looking for possible outcomes, you don't always have to do the table. You can also do something called the fundamental counting principle. So this is going to be an aside. It's called the fundamental counting principle. And what the fundamental counting principle is, I'm going to call this an aside. What it is this. I want to think about my total outcomes for the spinner. If I spin the spinner, what are my total possible outcomes? And there are 3 possible outcomes, right, for the spinner. Now, if you roll the four-sided dice, how many outcomes are there for the four-sided dice? Well, for the four-sided dice, there are 4 possible outcomes. So to find the total possible outcomes, you just have to multiply the total outcomes for the spinner and the total outcomes for the four-sided dice. And if you do that, 3 times 4 is 12. So notice how 12 are my possible outcomes. So if you just wanted the total possible outcomes, you can always just use the fundamental counting principle. Or you can draw a table, a sample space table, or draw a tree diagram if you would prefer a visual. Now, the reason why we were recommended in A to draw a sample space table is because of the question they're asking in B. The question they're asking is, what is the probability of getting a sum that has an even number? So sum that has an even number. What that means is, well, first off, we know our denominator is going to be our total possible outcomes, so that's going to be 12. However, our top number now, we have to ask ourselves this. If I add these numbers that I got from the spinner and the dice, which numbers would add together? Because sum means to add. and those numbers would be even. So let's have a look here. 3 and 1. If I sum 3 and 1 together, meaning if I spin the spinner, land on 3, and roll the dice and land on 1, what's 3 plus 1? Well, it's going to be 4, right? And 4 is an even number. So I have one number that's even. What about 3 and 2? Well, 3 plus 2 is 5. Well, that's not even. What about 3 and 3? Yeah, 3 and 3. 3 plus 3 would be 6. So that means that's an even number. So now I have two even numbers. Let's check 3 and 4. 3 plus 4 is 7. That won't work because that's odd. 6 plus 1 is 7. That won't work because that's odd. But 6 plus 2 works, right? 6 plus 2 is 8. So that's another even number. 6 plus 3 is 9. That won't work. But 6 plus 4 is 10. So that's another even number. 9 plus 1, that's 10. That's an even number. 9 plus 2 is 11. That's not even. 9 plus 3 is 12. That's another even number. Now let's check for 9 plus 4. That's 13. That's not even. But now if I want to add, so these numbers are the ones that sum up together, meaning they add together to get an even number. Let's count how many there are. 1, 2, 3, 4, 5, 6. So because there are 6 of them, I'm going to write 6 as how many numbers that add up together and become even numbers for my top number. And now my probability is just the sum of even numbers divided by my total possible outcomes. So I have 6 over 12. Or if I want to divide both top and bottom by 6, I can simplify this fraction to get 1 over 2 as my answer.